Are you okay so far? Do you get how it's done, the Pearson test? Um, do you understand how to do it?
No, I think it's easier when you just need this Ttest and manually doing the Pearson correlation. When we did that in let's say university time, I was studying. It's lengthy procedure, but
Yeah. Yeah, that's why this is what I was trying to say yesterday, that you don't need to undergo that hassle anymore. And as a researcher, even if you are not really that inclined to do math, you can still understand the process, okay, because it's easier here when we use the program as best. Just transferring. Can I send you the file in the chat box instead, so you can take it? It's because it's hard to challenges of technology. I'll send you the file so you have a copy of this too, because I think the one that I submitted to St. Roberts was the file that I did not correct yet. This one I corrected some parts. So please download this so you can have your own copy. It will serve as your handout to uh, how to report the data. Okay. Be able to download it. Okay. So we have the table here. Okay, and then we want to write a report based on this table. So we can say, to make the report more complete, we can describe the table first. Like you can say table number one, for example. Table number one displays the relationship between time spent watching television and cholesterol concentration. And then you state what statistical test you use. Okay. The Pearson's product moment correlation with the level of significance of 0.01 was used to run to assess the relationship between cholesterol concentration and daily time spent watching TV. There was a statistically significant correlation because remember, our results are significant, right? So we take this. There was a statistically significant correlation between daily time spent watching TV and cholesterol concentration. And then we show the value of R, which is 0.37, and the p value, which is p is less than 0.001. Okay, now you might be wondering what is this 98 value doing here? Okay, 98 is the degrees of freedom. We call it degrees of freedom. Degrees of freedom in statistics for for R in this particular case is we subtract 2 from your total number of respondents. So n minus 2. Your respondents are 100, right? So to know the degrees of freedom, 100 minus 2, that is 98. That's why we get this value here. Okay? So R, 98 is equal to 0.37 comma P less than 0.001 with time spent watching TV. Okay, meaning there is a significant correlation, right, between cholesterol concentration and time spent watching TV. The result leads to the rejection of the null hypothesis. Okay? So what we are doing here, we are just trying to present or create a report about our results. Okay? After you do this, okay, this is not only the paragraph that you see for your table. Okay, usually in the research, what we do is this is just the introductory paragraph. We call this the level one, and then you have other two levels that you include in your explanation. Okay, so you have level one, which is describing the table and the results. This is what we did here. Level two is you relate your results to your related studies in your review and related studies and review related literature. You relate the results there to your studies before. And then the third one is you create implications. Okay, you make the conclusions, okay, based on these results. Okay, so that's how you do it. But for now, since we are focusing on interpreting our results, we stop at level one. Okay, so this is how you do level. You describe the table, you report the results, and then you also report your decision based on the results. Since your results are significant, then your decision is to reject the null hypothesis. Okay? So this is how you're going to do it for Pearson correlation. Do you have questions? What are your questions before we proceed to the next step? Next test. Okay. So I'm going to share you my other screen because I'm going to discuss about the next test. So we're already done with the Pearson correlation test. And I showed you also a sample report on how to interpret the results, right? So let's now proceed to the next statistical test, which is the independent samples t-test. So what is an independent samples t-test? It is used to determine if a difference exists between the means of two independent groups on a continuous dependent variable and if that difference is significant. It is also known as the independent t-test, independent measures t-test, between subjects t-test, unpaired t-test, and students t-test. So these are the other terms of this test that we are trying to learn. So examples, determine whether salaries measured in US dollars differed between males and females. Is there a significant difference between the salaries of males and females? Okay, we can ask the question this way. Number two, determine whether reaction time measured in milliseconds differ in under 21-year-olds versus those 21-year-old and over. So in our research question, we can state it as, is there a significant difference on the reaction time measured in milliseconds between those who are aged under 21 years old or those who are 21 years old and above or and over. Okay. Now, I need to show you an example so that you understand, okay, what it means when we say statistical difference, a significant difference. But first, I need to show you the assumptions of the test so that when I show you the data later, it's easy for us to go through what it means. Okay? Now, what are the assumptions of the independent samples t-test? We have six assumptions. Sorry. The first one is the continuous variable. So it has to be in the scale measurement. Okay. So one dependent variable that is measured at the continuous level, at least one of the variables that you are trying to find out, okay, or trying to analyze is in the continuous level. And the other variable should be in the categorical variable. Okay? So when you say categorical, it could be nominal, it could also be ordinal. Okay, because nominal and ordinal values are categorical data. Independence. There is no relationship between the observations in each group of the independent variable or between the groups of themselves. Okay, meaning the data that you have from this particular variable must be completely different from the other variable. It should not be that I have a data here that I put in this other variable. It cannot be because that violates the independence assumption of the samples t-test. No outliers. So again, we only look at the significant outliers, those with the asterisks, okay? But if there are outliers that doesn't have the flag in it, the flagged outliers, meaning the asterisk, there is no need to do anything for that. Only those with asterisks. Normality, okay, so it has to follow the normal distribution, okay, or if it violates normality, it has to be a sample size that is more than 30 respondents, okay, then it's okay if you violate the normality assumption. Remember, central limit from yesterday, if your sample size is 30 and above, okay, then you can still proceed with the test even if the data violates the assumption of normality. Homogeneity of variance. So the variance is equal in each group of your individual variable, and then the Levene's test for equality or the Welch t-test is used. Okay, so you'll make sense of this later when I show you how it's done. Okay, let me show you in SPSS a sample of independent samples t-test. There's okay. So here is the example. So we want to find out, okay, if there is a significant difference between the male and the females, okay, in terms of their engagement with TV advertisements. Okay, we want to find out if there is a significant difference with their engagement with TV advertisements. Okay, now let's look into the assumptions of um, independent samples t-test and find out if our data passes these assumptions. First assumption, there should be one continuous variable. Okay, here, our continuous variable is the engagement. Okay, because okay, here, this is our scale. Okay, so this is the continuous variable engagement with TV advertisement. While the next assumption, the categorical variable, is sex. Okay, because we only categorize sex as male and female. So it is considered as a categorical variable, specifically nominal measurement. Okay? So we pass those assumptions. Next one, independence. We have to make sure, okay, that, okay, the data that you input for the male is not the same data that you input for the females. They have to be in different, they have different data. Okay, it can be that the data that I put male is the same data I put in the female. Now the next one is the outliers. So when you say outliers, we look at by looking at the explore option is the SPSS, just like what we did in the Pearson test earlier. And then what we're going to do is we are going to look at the engagement variable if there are outliers in it. Okay. So statistics, we click outliers because we want to find out. Okay. And then since we are here already in this in the explore window, let's also find out if our data is normally distributed because that is also one of the requirements, right? So uncheck stem and leaf, check histogram, check normality plots with test, continue. Okay, and then be sure to put both so we can see the graph and the table values. Okay, so okay, okay. Let's find out. Okay, let's look at the outliers first. Are there outliers? No, there are no outliers. So it's okay. Our data passes the outliers assumption of independent sample. Now let's check if our data is normally distributed. Is it normally distributed? I can't really decide by looking at the graph alone. Okay, now let's look at the Shapiro-Wilk value. So look at this value right here, 0.437. Remember, we need a value that is more than 0.01 for us to say that the data is normally distributed. Is this value more than zero point zero 0.01? Therefore, we can say that our data is normally distributed. So our data passes that assumption. Now, the last assumption is the homogeneity of the variance test. Okay, how are we going to find out the homogeneity of variance? Okay, so this is how we do it. In analyze, okay, and then when we try to test the independent samples t-test, from there we can already click on the homogeneity of variance test. Okay, now this is how we do it. We select compare means, okay, and then we select the independent samples t-test. So click. Now, our test variable is we want to know if there is a significant difference in the engagement, right? So that is our test variable. Usually the dependent variable is the test variable, okay? Because we want to find out if the independent variable affects the dependent variable, right? To test. Dependent variable is in place. Test variable engagement, the TV advertisement. Now the grouping variable, obviously, because the one grouped into groups female and males, right? Which is the we put that here, the grouping variable. Now, what is the defined groups? There are questions here. What is defined groups? What are the codes that we assign for the male and the female? Okay, so I did not show you that earlier, but it's right here, the values. It's coded that one is for the male and two is for the female. So we have to indicate that as well when we run the independent test. So doing that again, analyze, compare means, then click on the independent samples t-test. And then we want to know if there's a significant difference of engagement. So we put that here in this variable. And then they are based on two groups, females and males. Okay, so what are those symbols that we assign? Group was just symbol one, right? And two is two. There's one for male, one for females. So continue. And then we click OK. Okay, so here is the result. Okay, we are also shown with some descriptives here. We have the frequency meaning the number count on how many males, how many females, 20 each, right? We also have the mean, standard deviation, standard error. But we're not interested in that as of the moment. We're interested in looking at if our data passes the homogeneity of variance test. We look at this one here, the Levene's test for equality of variance. When you say homogeneity of variance, homogeneity meaning from the word homogeneous, right? Homogeneous meaning equal or the same, right? So, so we look to this part of your table, the V for equality of variances. Equality meaning homogeneity. Okay. So we want the test to be not significant. Okay. Not significant meaning our data passes the homogeneity of variance test. Okay. Now look at the sig value, 0.174. If our alpha is 0.05, is this value significant or not significant? 0.174 greater than 0.05? Yes or no?
Yes, it's 0.05 greater.
Okay, greater. Then it means that test is not significant, right? Then we want that to happen because we don't want a significant test for the homogeneity of variance. Okay? Levene's test, our goal is to have not significant result for it to pass the test. Okay? So here we can see that, okay, our data indeed passed the homogeneity of variance test because the sig value is not significant. Okay. Now, let's go look at the results of our data. Let's look at the T, okay, and the one that we're interested in, which is the sig value, because this is when we decide whether we reject the HO or not, right? By the way, we did not set an HO and HA for this particular study. What should be the HO here? There is no significant difference on the engagement between females and males. The alternative is there is a significant difference between females and males. Okay, look at here. We are interested in this value, the sig value, 0.023. Okay, this first value here of the sig. Is this value a significant value or not significant value? Look at the value. Is it greater than 0.05 or less than 0.05?
Greater than.
Less than. And then if it's less than, it means that the value is
Significant.
significant. Okay, so if it's significant, it means that what can we say in our results? There is a
Is
significant difference between males and females in their engagement with TV advertisements. Okay? So that is how we're going to say it. Now, what is our decision? The HO.
Reject that H.
Reject HO because the result is significant. When your results are significant, you reject HO. Okay? And then accept the HA. So how are we going to show that in our report? Okay, this is how we do it. Okay. So we have the HO, right? There is no significant difference in the engagement with TV advertisements in terms of, okay, sorry, it has to be sex, okay, not gender. There is a significant, or did I send this file to you or I already corrected it as sex in there? I'm not sure. But anyway, this has to be sex. Or you can say it, uh, there is no significant difference between males and females in their engagement with TV advertisements. Okay, so you stated that. So these were the tables that we saw earlier, okay, from SPSS. Okay, we have the descriptive tables. We also have the table on, we also have a table on the T-test, okay, which shows us the Levene's test or the homogeneity of variance test. And the one that we are interested in, okay, I cut the table because it's long. The continuation is right here. Okay. So we want to find out, okay, if, okay, the values are significant or not significant. Okay, so here it is. This is the one, 0.023 significant. So how are we going to write our report for this particular test? We summarize it into this table. Okay, table number 2, for example, comparisons between the engagement with TV advertisements in terms of sex. Okay, please correct it. So the T was 2.37. Again, two decimal places here. We got that from here, 2.365. We round it up, so it becomes 2.37 here. P-value, the p-value is right here. This one, 0.023. That's why you see 0.023. Significant, okay, because the value is less than 0.05. And then the decision is to reject the null hypothesis. Okay. Now, I'm not sure with your university, okay, what is the name of the university again? Samar State, right? Northern Samar University. I'm not sure if they require you to put in the mean values as well in the table, but in the other university they don't, so we have it this way. But in case they will, then we have to put another column right here on the means, okay, for the female and the male respondents. But anyway, you can also put that in your report, just like this one. An independent samples t-test was run to determine if there were significant differences in engagement to an advertisement between males and females. Okay. The advertisement was more engaging to male viewers. How did I know that? By looking at where is that? This table right here, the mean, right? Okay, the bigger mean is for the males, and then the lower one, which is the 5.2999, are for the females. It means that the male has more engagement than the females because it has a higher mean compared to the females. So I can report that also here in the report. You can say that the advertisements was more engaging to male viewers. Mean is 5.56 and the standard deviation is 0.35. Okay. Then the female viewers, which has the mean of 5.30, we round it off to two decimal places and standard deviation of 0.35. Okay. Which is also statistically significant, a statistically significant difference of 2.37, okay, and P is equal to 0.023. Okay. The 38 here is, by the way, the degrees of freedom, as what I've said earlier. There were 40 respondents, so degrees of freedom minus 2, that's 38. That's why you have the 38 line. Decision, the result leads to the rejection of the null hypothesis because the results were significant.
Uh, Dr. Kua, I just want to
Yes?
clarify. The degrees of freedom means like degrees of freedom is equal to the total sample size minus 2, right?
Yeah, yeah. Okay. Wait, excuse me. Okay, I need to, excuse me.